Another approach is to use modulation, so shifting our ideal passband to the desired position in frequency. In this way, we can turn a low pass into a band pass or a high pass depending on where we shift our passband. In this way, we can turn a new problem into our non-problem, the designing of a low pass filter. So the idea is that we design just the low pass filter and then we use modulation, so we shift to the desired position. And how do we shift our passband in the frequency domain? We convolve it in the frequency domain with a Dirac impulse at the desired center frequency omega 0. So here we have frequency response of our filter, and then we multiply with the Dirac at the desired center frequency omega, and then we will have our frequency response at the desired frequency. If we want to have real valued impulse response, we need to preserve the symmetry between positive and negative frequencies by also shifting the frequency response by the same amount to the negative frequencies. So we have here, this is the equations. We have this, we are shifting the positive frequencies and we are shifting the negative frequencies, and we end up with our filter. And how does this change our ideal impulse response? To answer, we take the inverse DTFT. So the convolution in the frequency domain becomes a multiplication in the time domain, and now we just need the inverse DTFT of this part here. And to obtain it, we can simply use our formula for the inverse DTFT. And remember that the integration of a function multiplied with a Dirac impulse is the function value at the position of the Dirac, and here is omega null. So we have that this is the resulting frequency response. Now we can get the inverse DTFT, which is now this, and we have this result here. So this is the function which we need to multiply with our ideal low pass filter to obtain an ideal filter where the passband is centered at around omega null. We call this cosine function a modulation function, and the multiplication with this function is a modulation. Observe that we can also introduce a phase shift p into this modulation function, for instance turning the cosine function into a sine function. This would still work because the frequency domain, in the frequency domain, this is a multiplication with another complex exponential from the phase term in the time domain, just like from a time lag. It would just introduce a phase change in the final filter.